All right. Good afternoon, ladies and gentlemen. Welcome to the StorTrends virtual lunch and learn on high performance storage systems. Sorry for getting started a little bit late here, but we wanted to give you everybody a little bit of extra time to get their pizza so you could start enjoying it before we got started with the presentation. It is an absolutely beautiful day here in Atlanta, Georgia, where we're broadcasting from today. We hope that you are somewhere nice as well. My name is Tyler Newberry. I'll be your moderator today. And we'll begin starting in just a few moments. But first, we have just a couple of quick housekeeping items. If you are one of those people in a coveted pizza delivery zone, your pizza should be arriving at the top of the hour or just a few minutes ago if it hasn't already. If you do have any problems, please do not leave a comment on the YouTube page. It'll take far too long to get that addressed and try to figure out who left the comment. Instead, please shoot me an email with your issue. You can find my email address underneath the description of the video. Sometimes you might need to click the show more button to view it, but it's tylern@ami.com. Again, that's TYLERN as in November at AMI.com. And that'll be much quicker for getting the issue resolved. While we're in the description section, you'll notice a couple of links there. Our senior solutions engineer, James Dykowski, will go through those a little bit during the presentation. And of course, you'll see our Twitter handle and LinkedIn account on there as well. If you follow us on either of those, we'll be able to tell you about future virtual lunch and learns, the latest and greatest in storage, and when we might be in your area for like a trade show, a VMUG, or maybe even something else. And last thing before we begin, there will be a short Q&A session at the end, maybe about 10 minutes or so. If you do have a question, feel free to leave a comment in the YouTube section below. If we have time, we'll get to it. If not, we'll actually comment on that comment a little bit later this afternoon to give you your answer. The other way to ask us a question is just to shoot me an email at tylern@ami.com. Again, you can find that email in the description. And we will shoot you an email this afternoon with that answer, again, if we do not get to it during the presentation. I know we're a little bit pressed for time, so with that, I will go ahead and introduce to you our Senior Solutions Engineer and main speaker for today, Mr. James Dykowski. James?
All right, thank you, Tyler. Yeah, I hope everybody's having a good day. I guess I'm used to responses. There's no way I'm going to get a response here. But anyway, so what we're going to talk about is just Flash and, how does everything kind of integrate together? And we have this this piece or this kind of new idea of snappy Flash. So making everything just really snappy, really efficient in the back end to make that happen. So one thing, we'll just start out with, AMI, who is American Megatrends, just so you guys don't think that we're coming out of the woodworks here. We are an OEM-based company. We've always been an OEM-based company. AMI BIOS is what we're most known for. You can see the little AMI American Megatrends triangle in the middle there. You guys might have seen that. Now, with Quick Boot and stuff like that, it's few and far between when you see that logo. But in some way or somehow, we're in more than half of the computers in the world today. You can also see the Mega Rack. The people with Dell servers, maybe you have an iDRAC card in there, something like that. Well, this Mega Rack product line to them, of which that is our product. Supro Doctor for Supermicro and others actually use the same OEM technology from us. So a lot of people have heard of LSI. Obviously, Avago just bought them last year, but they had the Mega RAID product RAID card there. So we actually had this team from American Megatrends build that product up, and very successful. We sold that off to LSI Logic in 2001. And we actually brought that team back, and that's actually the basis for our StorTrends storage SAN solutions here. So they've been working on that ever since, and now we're proud to really get up into the latest and greatest technologies and push forward. You can see we have a lot of patents. This is our technology. We've homegrown this whole, just the block-based idea, the whole OS, everything together to bring this together technology-wise. A lot of installations, and at this point, it's a proven technology. So we are happy to be on our 30th year. So so we'll carry on about Flash and how this integrates kind of in everybody's solutions. So first thing we'll talk about is, where is the general user at? You have spinning disks, give you about 50 terabytes worth of raw capacity with 5 shelves, say. And you'll be looking at latency of 7.5, 10 milliseconds, just depending on the workload, how many reads and writes and stuff. A lot of rack space though. Obviously, all these spinning disks, all these enclosures have power supplies, so it's drawing a lot of heat, a lot of power, a lot of CO2 emissions, all that kind of stuff, just depending on how green your company is. And of course, there's just a lot to manage there. And you can see the CapEx here of a lot of money to get this. So now we have this 3600. We previously released a year ago the 3500, which was a hybrid SSD disk array. Well, now we have the 3600, which is an all-flash array, but we've really got that cost down because of what we're doing technology-wise to make this an affordable, feasible solution going forward. You can see here, raw capacity is 7.2 terabytes, but with dedupe, and realistically, you can get to 50 terabytes very easily with this much capacity. You're looking at a way lower latency, and obviously just a lot less rack space, power, all this kind of stuff. And even better, the overall cost is reduced greatly with this. The operating expenses, of course, are also reduced. So now some people are saying, well, you know what, instead of this, I want to keep my old solution and I want to have kind of a server-side cache type solution. So I didn't name drop anybody or anything like that. But we're looking at that solution and what does that bring you? So a raw capacity, you're probably going to add about 5 terabytes or so in a 50 terabyte type solution, and that's 10%. Even if it's a little higher than that or a little lower, you're still going to be around the same type situation. Obviously, there is no additional rack space. The power is minimal, CO2 emissions are minimal, and the management, there is an additional UI that you would have to log into and kind of manage this. And I actually had one of my customers last week. I was like, hey, show me how much of an advantage you're seeing here, and da da da. And he couldn't even remember how to get into it to see it. All he could show was actually within VMware what the latency looked like. In latency, he is more of an OLTP type situation, so it's a very heavy write environment. He was seeing around 18 milliseconds, and that's not just peaks. These are more of average numbers for all of his writes, because the server-side cache, they had to mirror the data to another server. And then even worse, you eventually have to flush that down to disk and all that kind of stuff. Well, with all of that, it was a really heavily increased latency on writes. And that's a huge problem. Obviously, with databases and everything, we just want to keep latency as low as possible. So reads, though, super fast, 400 microseconds. And that's, plus or minus a little bit, depending on if you go with NVRAM versus an SSD, because the SSD obviously has to go through the backplane and the controller and stuff like that. But it's not a lot different. If you look at the overall value here, you're looking at about $5 per gig, just running the numbers on about a $20,000 solution with 5 terabytes. Very easy math there. Obviously, that increases and decreases, just depending on what you have. With the 3600, so now if we're just trying to compare, well, what if I did this solution versus this solution and where are you at? Obviously, you can do them in conjunction with each other, but there is issues. So the writes, the server-side cache would take that over from the array. So now you're not even going to see an advantage with the array if that's where the bottleneck is. Basically, it's waiting on those writes on the server-side cache side. So that is a consideration. You can't quite do just both of them and it just add in every time, unless it's a read-only type server-side cache, something like that. So with the 3600, it's the exact same as what we just showed, just kind of looking at it in a different light. Same capacity. Obviously, we're getting the whole 50 terabytes on flash, and that's with dedupe and compression technologies, stuff like that. But you can see here, your latency, it's 1 millisecond versus 400 microseconds. There's 600 microsecond different. It's not a huge difference, and this is under heavy load. So writes, though, we're going from greater than 10 milliseconds, just depending on what the load is, to under 4 milliseconds for writes, and that just depends between RAID 5, RAID 10, and there's a few variables there. So now if we look at this, okay, you know what? I don't have just reads. I don't just have writes. James, what does it mean for me? So on a 50-50 mix, you're looking at an average of 5.2 milliseconds for the server-side cache, to where we would be looking at 2 milliseconds, and that includes the latency of the network. On the server-side cache, 6733. So say you don't have 50% writes. Oh, it's less than that. Well, you're still looking at 3.5 milliseconds. We beat that with the 50-50 average. It's going to be even low. It's going to probably be a millisecond and a half on our side. It just, once you decrease the writes, it just helps us. So, and you can see here the CapEx. I mean, we're looking at $1 per gig for usable space, and it's all flashed out. You don't have to worry about misses and stuff like that. So, huge consideration there when you're looking at this. So now latency, it's just the huge topic lately with all, just all the all-flash solutions. So what does it take to get to 100,000 IOPS? How many disks would it take? For SSDs, it would easily take just 4 disks, and you could basically manage the 100,000 IOPS. With 15K, you're looking at 285 disks, and this is just reads in this case. And then 400 disks for 10K, about 500 disks for 7.2K. So it's a big variance, and obviously these blocks aren't even correlating to what the SSDs really take up usage-wise. So now at those loads, though, what are you looking at for latency? So now with those disks, you're at 1 millisecond for the SSDs versus 7.5 milliseconds for the 15K, or 12 or 15 even for the 7.2K. And obviously databases, that latency for the 7.2K just isn't reasonable, because the databases will alarm at 15 milliseconds. And you can actually see that. So right behind the blue block, there's that little dashed line, and that is that 15 millisecond line that you have to be under that, or you want to be under that, especially for your average load, but even for your peaks, because otherwise you'll get alerts from SQL saying, hey, threshold here, you need to either reduce the load, which good luck doing that, or you need to increase your speed of your drives. And obviously you want to be under 5 milliseconds. This is good, fast, and it's snappy. I had a customer that they upgraded their unit, and they were like, look, I want this thing to just be snappy. So we provided them that, and we did this. So so you can kind of see, where you need to be. And then, of course, over 50 milliseconds is bad. It's slow. You just feel like you're just waiting on this thing. And then you can see this other dash line on the far left. And now this 800 milliseconds line, if you pass this is almost like the black hole of no return. This is where you're like, if it's a VMFS underlying, it's going to lock up the data store and kind of go into read-only mode. So obviously that's a no-go. So that's kind of what you're looking at with these latencies, and where you want to be. And then everybody can kind of establish, we want this to be an average also. This isn't just peaks. So that's a huge note in all this. So how in the world can I make everything good, fast, and snappy? I just, that's the next step. So how can we get enough SSDs to do this? And obviously the answer is compression and deduplication. You do it inline, so you don't waste anything basically in background processes, and this data deduped, so it's going to take longer to get versus that data, or compressed. You don't want to worry about that kind of stuff. So we're looking at this chart, and it's just kind of a standard of knowledge here of, about 2020, we're going to be at about 44 zettabytes worth of total data. Now, if you were to reduce all this data down, I mean, and this would be a 4.4 reduction, you're looking at 10 zettabytes of actual space. And obviously a zettabyte is 1 trillion gigabytes. So it is a lot, but looking at the future of storage, we have to really focus in and understand that people are going to have to look at compression, deduplication, and even you can see Windows is doing it now on the NTFS layer. So everybody's growing that way, and this will be a more mainstream adoption for the future. So now looking at okay, well, what do we get with inline compression and deduplication? So we have this data, this given space here, say it's 5 terabytes, whatever. So what we want to do is, obviously compression, we want to shrink that down, just compress it as much as possible. Obviously things that are already highly compressed, things like videos, maybe even like a JPEG, I don't know, a JPEG and stuff like that. That stuff's not going to be highly compressible, but there are other things that are not compressed. So we've compressed those down, and we're doing this at the block level, so it's very granular. And then obviously any duplicates, so you can see the purple files here, the red files, we're just saving 1 copy and then just marking, hey, on the disk location in the metadata tables for us, this is where we're putting stuff. So, you know, if you have another red file come into this environment, guess what? You don't even have to write it to disk. So how much I/O does that save you? Depends on how big that file is, and depends on how many people are uploading same files and stuff like that. So there's a huge performance increase in this. And then even better, one huge concern with SSDs is that endurance. I mean, this thing's got a lifetime that's defined. You can only write to it so many times. So what we get to do with this is also say, hey, we're not rewriting this file. These are all savings here. And with our technology, because, you know, we've homegrown everything from the ground up, we're looking at about a 7-to-1 ratio on average. And that was actually one of the questions that came in from everybody. So on average, we're seeing 7-to-1. You know, just depending on what solution, you can actually see a better average. So we'll look at different solutions. So, you know, say we have these 10 terabyte volumes of backups of virtual servers, database, exchange, and user directories, okay? So now this would be a full volume at 10 terabytes. So what we'll do is, okay, what if we just compress that data? What are we looking at? So here you can see the backup, it only goes down to 9-something terabytes versus 10. The big saver here was the database, and it goes down to 3 terabytes from 10 terabytes. So now what if we just had deduplication? What are we looking at? And this, of course, is on average. So you can see the backup goes down to 30-to-1. There's just a lot of repeats, saved revisions, and stuff like that. You know, that you're saving over snapshots and all that. Well, you don't have to rewrite compacts in. Just say you had one file that you changed every day, for instance, of a month, and you only keep a month worth of data as backup, right? There's your 30-to-1 right there, and I could easily say that. So anyways, these are all the different solutions with just deduplication. So now when we combine these technologies together, we get even more out of it. So we went from 30-to-1 to 35-to-1. User directories, obviously it's the worst case scenario, but that is dividing all the data into half. So you can see we're at a 2-to-1 ratio there at a worst case scenario. So this is kind of how it all kind of works together, and what you would likely see in your situations. But of course, you know, it might be 5 terabytes of backups. It might be 2 terabytes worth of virtual servers, you know, and all that kind of stuff. So we take all these into consideration to basically scope out environments, but we have other ways of finding it as well. So now, okay, so how does this work in the application? You know, where would you end up being with SSDs and all that? So first we'll talk about VDI. It's a hot button topic everywhere. There are more and more people calling in, getting solutions quoted and pitched, and just trying to find, you know, the budget or the means to actually implement VDI, because there is a lot of savings into VDI. So with the old solution, so what we released a year ago, you know, it's a hybrid array. It has SSDs. It has tiering involved to hard drives. You can have up to 8 tiers, quite honestly. We also used caching to kind of mitigate the I/O going to the hard drives. We cache that I/O to keep it in SSDs and all that stuff. We have a lot of technology built into this, but you know, it's a little complicated of a solution. We wanted to simplify things. So the next step, basically, how do you get one tier? The caching drives for the temp OS, you can see the volume just disappeared because we don't have to resave that anywhere within the array because it was in cache. So everything now is just one big tier, and you know, you're using a lot less capacity. However, you know, it's all deduped and compressed. And even better, VDI, we're looking at a 17-to-1 ratio if it was just a VDI solution. So that's a very good ROI, basically, when you look at your dollar per gig, if that was just the solution that you provided. Obviously, we can mix solutions together and all that stuff, but this is the overall view. And, you know, you don't have to pin volumes. They all just get the same performance. You know, you're just maximizing all of your space all around. So now the next set would be databases. So obviously, you know, with the hybrid solution before, you only use the SSD tier layer for the hot data, quote unquote. And then the rest of it's, you know, it gets accessed once a day, once a month or something like that, maybe for a report. But other than that, it doesn't get accessed at all. So what do we do for this? Well, before, obviously, we had these pin volumes and difference. Well, now obviously it's just one tier. Everything basically gets the same performance, and you kind of roll with that. So very simple to use, very simple to see how you implement this kind of situation. So now if we go one more, backups and disaster recovery. So we have had our bread and butter being in how we kind of replicate deltas across the wire and stuff like that. We also have Riverbed or Silver Peak type WAN optimization built into our application. So it really replicates as fast as possible. Compressing, deduping the blocks. We've been doing deduplication this whole time, basically for the last 6 years within replication. Obviously, it's the same scenario as the others. You have all these different tiers. Before we could pin the volumes down lower and stuff like that, but now we don't even have to worry about that. Now it's just basically all one tier, and then even better, we have the use space versus the free space, and effectively, it all gets the same performance though. It doesn't matter the age and all this and that. So how do we kind of know this though? What are we using to say, hey, you know what, you guys have this X amount of hot data, and this much data is just kind of bland, or it's accessed once a day or something like that. Well, we have the iData tool. We released this last March, and what it does is you basically install it to your environment, and it'll tell you basically your performance needs, your IOPS, your throughput, the block sizes that we predominantly see on a server by server basis. And then now we actually have a dedupe. It's a separate iData tool within the same family there that can actually tell you your dedupe ratio if you're just in question about this. We do provide proof of concepts as well. So, I mean, there's really no harm in even trying if you just don't believe in dedupe or don't believe in compression. I was actually on site yesterday in Chattanooga, and the guy just has always been against that type of saving technology, space saving technology, and he was actually open to the idea of going this way. So I'm seeing more of an adoption of this, and just everybody realizing, hey, we've got to look this way going forward. So the iData tool, though, it's very easy to download, just a couple minutes, and then it's just utilizing the standard performance tools, WMI from Windows, the standard vSphere counters, stuff like that. And it's great for, you can see on the top right, Exchange, SQL. I actually have the Windows 8 there because we've actually done it to scope out individual user profiles for VDI environments. And then vSphere, you just put in the vCenter IP, and it'll actually load in all the hosts automatically for you. So very easy to use and all that stuff. So what does it give us? How are we getting data out of this? So I have 8 different customers. I know this is 4. These are centralized storage type customers. You can see the yellow. So this is 100+ accesses, and these are taken in the middle of the day. These are blocks with 100+ accesses within that last hour. So they're hitting multiple times. And even, it's a smaller percentage. This is all to a relative exponential scale. But there's an even smaller percentage that's getting 1,000 accesses or 10,000 accesses within that hour. But, 100 access is a good amount of access. So we do want to say, okay, that's our line. We want to make sure everything else is, hey, that stuff is our performance stuff. So you can kind of see in an infrastructure view, where are we at? You're looking at about 3% max of actual hot data that's really getting re-hit over and over and over. You can see the bright red is within the hour, and we're looking at a peak of 8% or so, something like that here. And then, what's accessed within a day? We're looking at almost, 29%, 30% right there of just touch sometime during the day. If that was previously completely hot data from 5 hours ago versus, just access one time, we can't tell that here, but what's important is that we want to cover this space. So now for databases, they're a little more lean. You can actually see how, the overall touch data, they keep these very slim, unless there's some like Company G here, their reporting tool kind of goes out of control there. But in general, the 100+ accesses is a very focused set of blocks that are in there. So what does this tell us? So now we have this data, what are we going to do with it? So now what we'll do is we'll combine these 2 charts. So we have the data store chart right here. And so now we'll overlay the other chart. So now we can see, okay, at the worst case scenario, this is accessed over one time in the last hour. Now this is 4 terabytes worth of space if you're looking at a 50 terabyte solution. And obviously we put all these on percentages to keep them on the same playing field. It's not rocket science, but it's not a scientific process here. Not everybody's alike, so there has to be a little gray area. Plus, even the people that are very similar, whatever, the day-to-day is going to be different. Monday's going to be different from Wednesday and Friday, stuff like that. So you have to kind of accommodate all these solutions. So this is 4 terabytes worth of space. So now if we look at, okay, well, what's accessed within the last day? Well, we're looking at, roughly 30%. So now that's 50 terabytes worth of space. What are you going to do to get that latency down? You're going to buy 4 terabytes worth of SSDs and plug it in there? I mean, that's going to be pricey in itself. And then 15 terabytes worth of SSDs, it's even getting more out of control. I'm looking at that. And you're looking at 30% solution to where most everybody will scope a 10 to 20% solution of SSD space to actual usable hard drive space. So you can kind of see that there. Now, if you get an all-flash array with dedupe and compression, and we get an average of 7 to 1 for an infrastructure, databases are obviously a little lower. We showed a 15 to 1 there in that example, but just say 7 to 1 because you have these user files and you have this and that mixed in there. That makes 50 terabytes down to 7 terabytes total. So now we're having just the data that's accessed in the last day of usable SSD space. So now if we look at, okay, access within the last hour, well, that's 570 gigs worth of space if we do the same ratio. And then, of course, it's 15 gigs of what's accessed within the last day. That's down to 2 terabytes. So you can see how by crunching this in, we can actually make this really cost effective. And the way that StorTrends works, we know where the hot data is. We know what the hot data blocks are. So we can actually make this happen even better than everybody else. So how do we do this? What are we doing that's special? No crazy stuff here that's brand new. We have read-intensive drives versus write-intensive drives. Any consistently read data or just old data that's not accessed at all, that goes into the read-intensive drives. There are no writes. We're not worried about write endurance, so we'll put them in there. We just monitor what block IO is doing what, and then, so in here you have the read data Z, block Z, whatever, and just say it consistently gets just read from. It's a video or something, and everybody's reading it off of YouTube. So now we have our write data, the Y. So now this is new data that's coming in, and it's just constantly getting updated. Say it's a database, say it's whatever, maybe it's a file that somebody's updating. So it's constantly getting updated. So it's constantly getting written. We want to make sure that that goes to the write endurance drives to just make sure that, hey, there's enough endurance for this. So with that, we can actually combine with what we know of how many writes are happening within an hour, 570 gigs in that case, and extrapolate that out to come up with, hey, how big is your write tier need to be? So we can kind of minimize what that is. And of course, what happens if that Z block actually gets written to? Well, we actually have, we missed the write tier there. We actually have in lift cache. So we're taking that hybrid solution, caching and tiering that we had before, and we're actually saying, okay, let's take the write cache portion out of that and plug it into this so that we're not duplicating any data, which we didn't do before between the cache and the tier. But we're making sure that the endurance on the read intensive drives are maximized. We're just saving that for as much as possible. So basically, we give a certain percentage of tier space to and lift cache. And so if Z gets written to all of a sudden, it turns into write data. We'll just throw that into cache and then basically blank out the Z drive on the read tier because that's not the latest block. Now, if it continually gets written to, we'll push that into the write tier. And even better, it's already technically in the write be you know, you can handle all these type of the right everybody else are if a drive ends up old or something like that, to where you can't see in there. That's you can't see the oh, I don't know what that is. So that we know, hey, this drive is about to fail. So what will basically happen is we'll send out an alert. It'll say, hey, this drive is reaching its end, or even better in an SSD scenario, hey, this endurance is getting really low. Go ahead and ship out a drive so we can replace it. And we do that automatically for everybody. Of course, we have 4-hour on-site available as well. All those kinds of things are required. So now the new product models that we look at, the 3400, this is just an all spinning disk array. 3500 is that hybrid solution still, to where we have the SSDs on the tier 1 versus the SSDs on tier, or I'm sorry, SSDs on tier, the spinning drives on tier 2, and kind of going down. We can mitigate, what performance gets where, and do quality of service with drives. Now, with that would be somebody that's uncertain of dedupe and compression technologies, and hey, you know what, just store my data and manage, where the blocks go. Now, on the other side of things, 3600, 3610, the idea for the 3600s, keep costs as low as possible, but give and enable the, the entry-level users the ability to get flash in their environment. So this is an all-flash array, but we max out the raw capacity to where the 3610 is that larger solution at 256 terabytes.
Hey, James, let me just stop you right there. It looks like we're having a couple of technical difficulties. I've seen on our side a couple of screens have gone to the StorTrends S logo. Apparently, we're still getting some live feed from the vocals. However, apparently the feed from the visual is not doing so high right now. We're going to check on that real quick. However, I know we are kind of pressed for time here, so just bear with us. James, you can go ahead and continue with your discussion, and we will try to get that picture back up for you guys ASAP. Again, we apologize.
Oh, thanks, Tyler. So yeah, sorry you guys can't see that. If you do need to see it, quite honestly, just call us. I can obviously present this at any time. It's just easier to talk to all you guys all at one time and give y'all pizza and take care of everybody. So so now just specifically looking at the 3600 and 3610, we are looking at just a lot of performance. And this performance, though, again, we're not looking at IOPS. In general, everybody we talk to is under 100,000 IOPS, and that's why I kind of used that as a mark before. Really, and again, it's exponential of, you get down to 50,000 IOPS, maybe there's, 10% of our customers that are something like that, and then you kind of go down from there. We do have customers that are up there and stuff like that, but we're really looking at latency, and that's the key point here. So the difference is, though, 16 CPUs, 64 gigs versus double the CPUs and a lot more RAM. And basically all this is to basically handle that 256 terabytes worth of space, and of which, I mean, there's overhead with compression and dedupe, so we did have to beef this unit up from the previous models. And then the right tiers, of course, there's capacity things, so we did put solutions together that will kind of maximize what you'd reasonably see out of the solution, looking at percentages of minimums and stuff like that, because you do want to be at least at the 5 to 10% for, your right tier, and kind of managing all those kinds of things. But we can put any kind of model together. So when we get our iData report back, here we can have 2 or 4 200s, 400s, 800s, up to 2 terabytes for the right tier. And then for that read tier, 14 or 12, 128, 256, 480 or 500. They have crazy numbers, 1 terabyte drives. for that piece, and then we just put that capacity together and fit you in. Network, we have plenty of space there when it comes to, throughput. Capacities, 64, 256, and then the new features, you can see the compression deduplication. Of course, ESX6 is rolling out in March. We will have support for that. And then the iData enhancements of Linux support, dedupe and compression support. And then the expansion capabilities. We can add shelves to these units to get your capacity up. So now, I've never heard of you guys. I don't understand, what I'm looking at, who you guys are, what have you. We've had a few analysts, stuff like that. If you haven't heard of who we are as it is, they've reviewed our product, they've compared our product. SSG Now kind of looked at iData. Tenasia, they came in-house. You pay them to come in and make sure that they saw the claims that we're making. And then Storage Review, they actually will take your unit into their lab and basically run their gambit of tests on it. And you can actually see the Storage Review right here just to show you guys, I'm not hiding anything, whatever. And obviously it helps that we're at the top, but we had more IOPS on 30,000 virtual users for SQL, and even better, that lower latency, 41 milliseconds versus the next player, which is 133 milliseconds. So we are keeping everything as low as possible. You can see in VM Mark, so it's basically just adding a bunch of tiles for VMs kind of setups and stuff like that. And you can see we were right there on top. XIO did have a little bump on us, but they had 2 more SSDs than we had. So an unfair advantage, but it's fine. We were still in there. And so now, customers, we have all kinds of different customers in different verticals, stuff like that. Kind of, been around the block with universities to, there's science type labs, retail, there's definitely the Army and stuff like that, just governments and everything. So, just depending on what kind of situation you're in. If you're in a bank, we have investment houses, we have even FSG banks somewhere. Custom here, and vertical up like that. I was just on site yesterday. TGA Office Automation, they're using us as centralized storage, but then they also have bidirectional replication. Centralized storage. To them. LERN at AMI. Like that down the road. And so we do have questions from what's your average at earlier, 7.3 to 1. I use 7 to 1 just to even be on the lighter side of that as much as possible. And does dedupe affect performance? So of course dedupe and compression affects performance. There is overhead in that because there's our metadata table, but then there's also the dedupe table. So now you do have to kind of cross-reference those, and there's a lot of stuff like that. So plus you also have to undedupe data if you're reading it out, and you have to dedupe it when you're writing it. So that's why we are utilizing SSDs though in this regard, to make sure that we mitigate that performance and give you kind of the value of latency and going forward. The third question is VDI a heavy read or a heavy write application? And that is a big depends. I do have let me go back here. If this thing will load faster, I think there's a little overhead with Google Hangouts. So IOPS, no. So there's application. So here we go. So you can actually see in this slide right here, what, VDI pitfalls was kind of one of my topics one time, because people wanted to understand, hey, what could happen here. So you can see the rights and the overhead with that on the right side in that chart there. And then on the left side, that depends. So it depends on your type of user, and you can see the IOPS requirements there. So that's kind of standard, 3 to 7. It's just a light, library user, to where a power user, you're gonna be on that heavier side. And of course, the heavy user would be somebody using a CAD or something like that. But as you step up those IOPS requirements, it also ends up being more rights as well. And that's just the OS updating and all that kind of stuff. So there is a lot with regards to the type of users that you have. So this does depend. In general, we consider it a 50-50 just because the rights are the heavier side of this. So to be on the safe side, I always go about 50-50 if I don't know what the overall solution is exactly. The other question, does StorTrends prevent cold data from being on high performance drives? Oh, how does StorTrends prevent cold data? So StorTrends has the tiering technology, and I ironically kept this slide. It's really very random that I kept this slide. And so this is normally what I show after that hot data, or what I used to show, because this actually shows spinning drives in kind of different zoning, because we do make sure that we write to the outer tracks for the latest data, and then the old data goes kind of to the inner tracks. But you can actually see, we're watching block by block how many times they're being accessed. So you can see this 9 right here. This is class 9. These are all the blocks that are accessed over 20,000 times within the last hour. So we're actually monitoring that and basically saying, okay, hey, this block is a very heavily accessed block. We're going to keep that, in this case, on the hot zone of the tier 1. So we're doing the same methodology. Obviously, with SSDs, we don't have to worry about zones, but you can basically see how in the tier 1, we have over 2 terabytes worth of warm and hot data, which I'm just saying accessed within the last hour at least one time. So that 2 terabytes versus 30 gigs that's in tier 2. And this is a worst case scenario type customer, is why I actually show this, because it is always moving the data around and stuff like that. It's randomly getting customer data. So, and then the last question is, how do I tell how much hot data I have? And really the iData tool is the solution there, to basically see how much hot data you have, and kind of how much, we'll see how much hot data you have, how many times, how heavily they are being accessed. But at the end of the day, as long as we're replying within a millisecond, it just doesn't matter. And even worse, with a heavy read and write workload, we're around 2 milliseconds under that. So, and these aren't marketing numbers. I'm not giving you, the sales marketing stuff. This is the real numbers here. So, so there's that piece. And so now what we'll do is, I'll just take the last second just to show everybody, there were a couple partners, couple customers that wanted to see the latest UI, because there have been changes made to this. And we had to change units earlier because Google Hangouts just was not participating. So I am not already logged in. That's the only reason for that. Okay, and I did not do, not on the standard network. Okay. So, okay, so yes, log me in here, and okay. So now, basically, I'm gonna drag this over to the screen so you guys can see it. And so now you can see the actual UI here. I only have a couple seconds. I got Tyler in here about to kick me out. So we have Google Chrome. We've used Google Chrome, Internet Explorer, Firefox for whatever. And so now you can see up at the top here, we have our discovery pane. So now it's very easy to basically access multiple nodes within the same infrastructure. Here, I'll just hide this pane here. And so now I actually have a workload going on I also have some video going on to get some reads and stuff like that. So you actually see the iometer here. We're looking at 30,000 IOPS, something like that. And here's the capacity. So you can see the physical capacity of 2.7 terabytes. Given this, in this case, I have a 10.4 to 1 ratio. You know, I'm looking at 27 terabytes, 28 terabytes usable. But I'm only using 28 gigs worth of space for 216 gigs worth of volumes. And even better, you know, this gives you space for snapshots and stuff like that and changes. So, so a very easy way to see everything. So if you scroll down, this is an overview of the actual the unit, basically all of the volumes within the unit. You can see I have 67.33% read write. You can kind of see a latency here. I know these writes are actually really heavy writes. They're 4K blocks, so it's the absolute worst case scenario for them. I must have just had that test in right there. And you can hover over, basically see what your throughput is, read, write, you know, all that kind of stuff. And then even better, we can kind of see volume. So you can see volume statistics right here. And you can select on the volume. Hello 3 is the one that we're actually running I/O to. So you can kind of see what this looks like in this regard and all these averages and stuff like that. If we go on the left pane, we still have all the other views available. Here's a storage pool. So now, of course, for this storage pool, we can have up to 8 storage pools. So there's quite a few different scenarios we can be in there. But you can kind of see the, you know, which arrays do you have, how much tier space are you using, you know, the background functions like demotion, you know. So by default, we'll keep data in there for a week in the write intensive tier, and then demote it down if it just hasn't been touched again. And we claim it's just none touched. So now you know, you don't know what to do with it. So now we actually have policies for that, and you can increase and decrease these just depending on how much space you're using within those particular tiers. Then we also have promotion policies. So if a block actually is read too heavily, we can actually say, hey, you know what, go ahead and promote this thing if it's got over 32 accesses within an hour. Volume specific stuff, you know, this Hello 3 volume is kind of my default volume. That's the one I'm logged into right here. So top 3500, that's my hybrid array. Let me go. So I just want to show you this. So this is logged into right here. And so you can kind of see, you know, IP information, you know, what to log into, how many paths do I have to this thing, you know, what kind of snapshots do I have. You can see I have hour, you know, I'm keeping the last 5 hours worth at an hour granularity, last day for every 7 days, stuff like that. And then down here you can kind of see how much performance or space you're taking on individual tiers and stuff like that. We do have all the regular performance monitoring as well from before, so like our SRM charts and stuff like that. Oops, I unclicked it. So you can kind of see, you know, for information lifecycle management, you can actually see how many times are we accessing these blocks and where are they. So now this class 2, that'll start all demoting down and stuff like that. Workflow management. So we're actually watching, you know, how heavy is this workload on an hour-by-hour basis within the day, within the days of the week and different days and stuff like that. So then with that, we'll actually reduce the amount of background functions that we do and all that kind of stuff. And of course, replication, there's a full-on wizard basically. Just put in the IP of the other units, log in, and it'll basically configure replication for you. So just very easy to use and stuff like that. And then when it comes to health, we actually show a picture of the unit. It'll actually show the I/O load on the drives, all that kind of stuff. So you can actually see the write-intensive drives are getting hit. They're the yellow drives. This is a 3600, it's not 3610. So the minimum is 2 drives like we showed before. And then the rest of these are just our capacity, read-intensive drives, basically going forward. So rear view, so you can kind of see, hey, you know, what's the status of these NICs and stuff like that. You can also see memory utilization, CPU utilization, and all that kind of stuff. So just a very easy view of kind of what's going on within the unit, you know, IO-wise and all that kind of stuff. And of course, we have full event logging. You don't have to putty into our system. If you had some scripts or something like that you wanted to run, you could do that from right here and everything. So, so I guess that sums us up. Tyler, were there any other questions?
Yeah, we actually did get emailed a couple of questions while the event was going on. We've only got about 5 minutes or so here left, so the other ones we will just the other answers we don't get to, we'll email out directly. But the first one came in a little while ago. I apologize if you already kind of glossed over this, but if you could tell me about how the average dedupe compression ratio works in the StorTrends array.
How the actual ratio works?
Yeah, like what is the average ratio, and how much does that fluctuate between environments?
Okay. Well, you should apologize because we did talk about this, but it's fine. It's absolutely okay. And so that's what we talk about here. You know, when we're looking at the overall solution, you know, there are different variables for how much backup space one customer has, how much virtual server space, you know, VDI type space, and all that kind of stuff. And so then basically we'll take these spaces and actually kind of configure a lighter side of all these values to make sure that everything will fit, will make everybody happy, comfortable basically with the solution. And that gives them plenty of room to grow down the road.
Well, very, very cool, very cool. And next one we have another question, and I guess we have probably time for about two more. This more relates to VDI. Is VDI a heavy read or a heavy write application?
Oh, yeah. No, I did that question already. Yeah, I've already done all those, the written questions that came in from before. So, yeah.
Okay, perfect.
Yeah, we talked about that stuff. So.
Well, perfect. Well, with that then, I think this might be a good chance to go ahead and wrap up a little bit. Did you already get to everything regarding the iData and pressure generator and all that good stuff?
I did not touch on any of that stuff.
Very cool. Well, one quick side note, just to give you guys a little bit of a goodbye. Some of you have already downloaded the iData tool on the description page just below the StorTrends YouTube link or StorTrends YouTube video page. You feel free to download iData if you're looking to get a little bit better assessment of your environment, especially if you're planning a project in the next few months and want to learn a little bit more about your hot data and how much of it you have and where you should be keeping it in regards to your storage array and flash storage. And also feel free to check out the price quote generator. If you do have a project going on and you're looking to get an MSRP quote, just to kind of give you a better impression of StorTrends, where our pricing comes in and how we might be able to configure exact configuration for you. Again, those will be an MSRP quote. Everybody, have a wonderful day, and let's know if we can ever do anything for you. Bye-bye.